Hi students, welcome to Sunil's tutorial. I'm Sunil Midwani and today we'll be doing this chapter of chemistry called as chemistry of carbon compounds. Let's start guys. Chemistry. How do I define chemistry? Chemistry is defined as a science concerned with structure and behavior of atoms, compositions and properties of compounds, reactions, energy exchange, and laws. These are the various things that you study about chemistry. So chemistry is a science which is concerned with the structure and behavior of atoms, composition and properties of compounds, reactions, energy exchange and laws. Now guys, when we talk about chemistry, chemistry is further classified into three categories. Chemistry is further classified into three categories: physical chemistry, inorganic chemistry and organic chemistry. Chemistry is further classified into three categories: physical chemistry, inorganic chemistry and organic chemistry. What do I learn in physical chemistry? Physical chemistry deals with fundamental principles, laws and theories. Fundamental principles, laws, theories. Right? Inorganic chemistry. What is inorganic chemistry? Inorganic chemistry deals with the study of compounds derived from non-living matter. Deals with the study of compounds derived from non-living matter. And finally, organic chemistry. Organic chemistry is nothing but it is the chemistry of carbon compounds. This is chemistry of carbon compounds. That is what is chemistry. Now, if you are talking about chemistry, let's see carbon compound. Carbon 12-6. Atomic mass number is 12, atomic number is 6, right? So I can say mass number is 12, atomic number is 6, right? Its electronic configuration is 2,4, which is also 1s2, 2s2, 2p2. Valency of this is 4. Why do I have a chemistry for carbon? Because of an unusual property. What is the unusual property that it possesses? It possesses an unusual property called as catenation. What is catenation? Catenation is the ability of carbon atom to form covalent bonds with other carbon atoms. Ability of carbon atoms to form covalent bonds with other carbon atoms. And it is because of this property that you have long chains and rings, right? Next, what do I understand by organic compounds? Right? What are organic compounds? All compounds of carbon excluding metal carbonates, oxides, cyanides and sulfides of carbon are organic compounds. What are organic compounds? These are all compounds of carbon excluding metal carbonates, oxides, cyanides, and sulfides. Now, let's find out the difference between organic compounds and inorganic compounds. Like difference between organic compounds and inorganic compounds. Difference between organic and inorganic. Right? Organic compounds besides carbon contain hydrogen, oxygen, nitrogen, sulfur and phosphorus. These are the compounds that they contain. Inorganic compounds are made from any of the 110 elements. From any of 110 elements. Right? Organic compounds are joined by covalent bonds. Inorganic compounds are joined either by electrovalent bonds or covalent bonds. Joined by electrovalent or covalent bonds. Right? Organic compounds are insoluble in water. Inorganic compounds are soluble in water. These are volatile, that means they easily react with air at room temperature also. So they are volatile, these are non-volatile. They have relatively low melting point and boiling point. They have high melting point and boiling point. These burn readily, right? They are difficult to burn. Points should be sufficient. Besides this, there are other points. There are other points that you have, like if you consider organic compounds, they do not conduct electric current in molten states, whereas inorganic compounds conduct electric current in molten states. Organic reactions are slow and complicated. Inorganic reactions are fast and rapid. Organic compounds have characteristic odor. Inorganic compounds are odorless. Fine. Right. Next, let's classify organic compounds. Let's classify organic compounds. Now, when you talk about organic compounds are classified into two classes. One is called as aliphatic. Right? Aliphatic, what are aliphatic compounds? These are open chain or straight chain compounds. They are open chain compounds. Right? Now, aliphatic compounds are further classified into saturated and unsaturated. What are saturated compounds? Where there is a single bond between carbon and carbon. What are unsaturated? Where there is a double bond or a triple bond between carbon and carbon. So when the carbon valency is satisfied by a single bond, then it is saturated. When it is satisfied by double or triple bond, then it is unsaturated. Right? Saturated hydrocarbons are alkanes. Right? Alkanes have single bond between carbon and carbon. They have general formula CnH2n plus 2. Right? Unsaturated hydrocarbons are further classified into alkenes and alkynes. Alkynes have double bond between carbon and carbon and their general formula is CnH2n. Alkynes have triple bond between carbon and carbon and their general formula is H2n minus 2. Right? So this was aliphatic compounds. Right? Now, the next classification you have closed chain. This was open chain. You have cyclic compounds which are closed chain compounds. Right? Now, cyclic compounds are further classified into two. They are classified into carbocyclic and heterocyclic. Carbocyclic and heterocyclic. Right? Carbocyclic are also called as homocyclic. They are also called homocyclic. Now, what are carbocyclic compounds? Carbocyclic compounds are those compounds which contain rings of only carbon atom. They contain rings of only carbon atoms. Right? Now, when you talk about carbocyclic or homocyclic, they are further divided into two. They are further classified into two. One is called as alicyclic and the other is called as aromatic. What are alicyclic compounds? These are closed chain ring compounds having rings of only carbon and properties similar to aliphatic. So they are closed chain compounds having only carbon in chain in closed rings and have properties similar to aliphatic. Although they are closed chain, they have properties similar to that of open chain. Fine. Aromatic. This is a special group of cyclic compounds. They usually have 6-membered rings. Aromatic compounds are made up of 6 members. They have alternate double and single bonds. Alternate double and single bonds. Right? And they show typical characteristics property. Show typical characteristic properties. So these were carbocyclic or homocyclic. Now let's come to heterocyclic. Now what are heterocyclic compounds? These are closed chain compounds in which the ring contains one or more atom of some other element other than carbon. These are ring compounds in which the ring contains in which one or more atom other than carbon in ring. These are heterocyclic. That's your entire classification of organic compounds. Right. Next, let's move on to the next thing. Now, what do we understand by functional group? Okay, I'll do this here only. Then we see the functional group table now. Functional group. What do we understand by functional group? Now, what is functional group? It is an atom or a group of atoms which defines the structure and determines the chemical properties of an organic compound. Right? It is an atom or group of atoms which defines the structure and determines the chemical properties of a particular class. Right? So that is what is a functional group. That means, in short, if in an organic compound, if I replace a hydrogen atom with another group of atom, then the other group of atom that I am going to be using, that will be called as functional group. Now let us see what are the various classes of atom that you can have. Let's see the functional group table, guys. Class. Let's consider alkanes. The first is basic is alkane, right? The functional group is C and C. There's a single bond between carbon and carbon. Example, ethane. Carbon-carbon single bond, 3 hydrogen here, 3 hydrogen here. Right? Those are alkanes. Next, alkenes. What are alkenes? Alkenes are carbon-carbon double bond. Example, ethene. H2, H2. Right? Next, third, alkynes. Carbon-carbon triple bond. Carbon-carbon triple bond is alkynes. For example, ethyne. HCCH. Triple bond between carbon and carbon. Next, you have carboxylic acids. Right? The next group that you have is carboxylic acid. Right? What are carboxylic acids? They have functional group COOH. Carboxylic acids have functional group COOH. Fine, we get this thing here. Now, in that case, let's see an example of this. The example of this is going to be acetic acid. CH3COOH. So COOH is carboxylic acid. The next functional group you have is alcohols. Right? Alcohols is nothing but OH. Right? Example, ethyl alcohol, C2H5OH. Right? The next functional group that you have is aldehyde. So that means that particular structure you have to know that COH is known as carboxylic acid, OH is called as alcohol, aldehyde is CHO. CHO. That is what is aldehyde. Right? Now, in this case, you can have acetaldehyde. Acetaldehyde is CH3CHO. Right? Do we get this thing here? Next, the next functional group that you have is ketones. Right? What are ketones? Ketones are nothing but CO. That is ketones. Example, acetone. CH3CCH3. That's my ketone. Right? Next, the next functional group that you have is esters. Right? Esters is COO. Right? For example, you can have methyl acetate, CH3COOCH3. Then the next functional group that you have is ethers. The next functional group that you have is ethers, which is nothing but COC. Right? Example that you can have is diethyl ether. That is CH3OCH3. The next you have is amines. Amines are nothing but NH2. Right? You can have ethylamine. CH3NH2. That's your amine group. Next, the next functional group that you can have is cyanide. Right? Which is nothing but CN. Right? You could have ethyl cyanide. CH3CN. And the last function group that you can have is halide. That is X. Those are halogens, where you could have example ethyl bromide. C2H5Br. Right, do we get this thing here? So these are all the functional groups that you can have, right? Starting from alkanes, alkenes, alkynes, carboxylic acid, alcohols, aldehydes, ketones, esters, ethers, amines, cyanides, and halides. Right? Next. What do we understand by homologous series? Right? What do we understand by homologous series? Now, guys, let's see this. Let's see this. For example, let's consider methane. Methane is, guys, CH4. Let's consider ethane is CH3, CH3, propane, CH3, CH2, CH3, butane, CH3, CH2, CH2, CH3. Similarly, I would go on. Pentane would be CH3, CH2, 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 CH3. Now, what is so special about all these members, right? What is the characteristics that they possess, right? They all have the same general formula. They all have the general formula CnH2n plus 2, right? They all have the same functional group. They all belong to alkanes, right? Next, each member differs the other member by a CH2 group. Look at this. The difference between this and this is CH2. The difference between this and this is CH2. The difference between this and this is CH2. So I can say each member differs the other by CH2, right? Now, that means if they differ each other by CH2, in that case, their molecular weights would differ by 14 because carbon is 12, hydrogen is 1, there are 2 atoms of hydrogen, so 14. So I can say that the molecular weight differs by 14, right? They all have same methods of preparation, same methods of preparation. Such a series is called as homologous series. So what is homologous series? Homologous series is a series of compounds which have the same general formula, same functional group, differ each other by a CH2 group, molecular weight differs by 14, have similar methods of preparation and belong to the same family. Right? Such a series is called as a homologous series. Right? Do we understand this? We'll stop this here for the day. Thank you very much.